Hello guys, welcome to my second tutorial on Max MSP, and this is my first tutorial in English. My English is very bad, so I hope you understand something of what I say. And this tutorial is about how to build a particle system with Max and JIT.gen. So let's begin. First of all, let's create our GL context. We have our toggle, qmetro, which triggers these messages with arrays and to bangs to JIT GL render. Let's call this tooth02 and race color black background. Alright, let's create our window. Tooth02 floating and just this for a moment. Right, now let's just create a bang. JIT noise with 3 planes, type float 32 and 250 by 250. This is the number of our particles, 250 by 250. It's a pretty big number. So let's create a JIT.gen object, but before we connect this matrix with the JIT.gen, we create another matrix which is the position of our particles. So we create another matrix because we have to memorize the position of our particles frame by frame. So let's create a sender which sends our metro, and let's create our receiver. We plug it to this matrix. So now ready. Let's call this JIT.gen force, because this is where we are going to calculate our moving force for the particles. Right, so let's open this guy, and what we want to do here is to calculate our force which drives our particles. So first of all, we need to create a vector which is the representation of a force. But let's see, I made a little graph on what is a vector, and there it is. It is basically it is formed by a direction represented by this arrow and by a magnitude, also called length, which is the strength of the force, the strength of the vector, and also is yes, how much this vector is long. And this is the head, the direction which the vector points is the head, and that's the tail. And this is useful because we are now going to create a vector from 2 points. So this is our center, which has 0, 0, 0 coordinates, is the center of our GL world. And we are going to create a vector that goes from the initial position of the particle to the center. So I made another graph. There it is. This is the center. Those are the particles. And we are going to create a vector that goes from the particle's position to the center. Let's see how we do that. We do Oh god, I hate this. We do that by simply subtracting our position from the center. So this is now a vector that points to the center, and as length is the distance from the particle's position to the center. So we are now going to calculate this length with the length object. We're now going to square it the length, and we are summing to this number, which is just a scalar. We are summing this little number to avoid dividing by 0, because we are going to divide our attraction parameter by the square of the distance, and this is because of the inverse square law, which states that a force is inversely proportional to the square of the distance, so that the more distance there is, the weaker is the force. Right, so let's create this parameter. This is our attraction parameter. And now let's multiply this number for the initial vector. This should be normalized, but since we are dealing with JIT noise, which is in the range 0,1, this is already normalized, so we don't need to normalize it. And this is our force. We just created our attraction force from the particle position toward the center. Alright, so we are outputting this force, and yes, but we are not done yet, because what we want to do is calculate the force as mass by acceleration. We already have the force, so what we need now is the acceleration, which is the force divided by the mass, but we don't have any mass. So we are going to duplicate this matrix, which is now our mass matrix. So this is the initial position, and this is our mass, and we are going to divide our force by our mass, which is in the range 0,1, but we multiply it by 2, so it's in the range 0,2. We add 1, so now we are dividing by 1, 2, 3 our force. So let's divide our force by our mass. We just choose some mass at our choice. We freely choose our mass. Right, so now we have to update our location, the location of our particles. So let's create another JIT gen. Let's call it update, and what we are going to do here is just multiply this for another parameter, which we call delta t, and we express it like that. This is just a scaling factor for our acceleration, right? So we are summing this is the acceleration with the previous position, and we get now the new position of our particles. This is the matrix containing the new position of our particles. New position. So that's the initial position. This is the actual. This is the position in this frame. in the old frame. This is the new position. So let's write old position. This is our old position, this is our new position. And let's plug this into GTL mesh. Alright, let's call it, and let's give it the attribute draw mode points and point size 2, because our particles are actually vertices in a mesh. And let's give it the color, let's make it all white. So let's create our actual attraction parameter. Attraction parameter for our force calculation. We gave it a value of 0.1, but we can change it. And let's see if we are actually drawing something. Yes, here we are. Our particles are slowly going through the center, but we can eject the matrix, reject them from the particles from the center. We can reject them or attract them. Where are you, particles? Let's begin again. So this way they're rejected, this way they're attracted. You see? Yes, because we are reversing the vector this way. All right. So the particles get rejected or attracted. But yes, that's super cool. But let's now do something more interesting with our particles. Let's give them some other forces. So, for example, we can make them follow the mouse moving in our window. To do that, we need some data from the JIT window. Alright, we need to get to the sides of the window, and we need also to give this window its attribute idle mouse. So we're now getting the mouse position out of the right outlet of the window. Let's unpack this value. We got a symbol which is idle and the 2 integers. Yes, but we also need to root the sides of the window out. So we need to unpack them. There's also, oh sorry, those are also integers. We need to unpack them, and we need to divide them by 2. The sides of our window, we need to divide the sides by 2, and we need to subtract those sizes from our original, from our position. So we are just translating the 0, 0 coordinate in the center of our window. Are you following me? This is pretty simple, pretty basic. It's done in every graphic program. So we're just translating the center of the window. Alright, so we are now normalizing it by dividing our coordinates by the half of the sides. So we get normalized coordinates. We have to reverse the y axis because OpenGL actually has reversed the y axis. We have to pack all the stuff. And we now send this stuff to a mouse parameter. Let's create a mouse parameter which we will input in the JIT jump force. Right, so this we plug it here. Let's pack this stuff. Let's call this mouse stuff. All right, And yes, let's change the center with the mouse. So we are now getting a vector that goes from our particles position to our mouse position. We need to click on the get sides message, and we see our particles which are trotted by our mouse. Isn't this super awesome? Yes, it is. Alright. But can we do something even more awesome? I guess we can. So let's just add another force to this mouse attraction. So let's add the original center attraction to the mouse attraction. Oh, we need another 0. Let's do the same thing we did before. We just create a vector that goes from our particles position to our mouse position, and let's multiply this by some attribute of some number of our choice with the param center at 0.2. Let's multiply, and let's just add this to the mouse attraction force. So we are simply summing force, as simple as that. Now the particles will be under two forces, the mouse attraction and the center attraction. Let's create the actual message. Center actor. This is the center actor. Let's see what we get. Hello guys, wouldn't you go to the center? Yes, but let's now reverse the mouse attraction and see what we get. So now the particles are rejected from the mouse but attracted from the center. And these guys, this is super awesome. But let's now do something more, just a little thing, but what I'm trying to say is that this new thing adds a lot of interest to our particle system. Because what we need to do is just to follow this principle, which is that the acceleration it's equal is summed to our force, our velocity is summed to our acceleration, and our position is the result is summed with our velocity, and then our acceleration is zeroed. So what are we missing? We miss a velocity parameter because we just have our acceleration and we need our velocity. So to do that, to add some sort of continuous motion, we need to add the acceleration to a velocity parameter. So let's create another JIT-gen, let's call it velocity, and what we are doing here is just sum the acceleration with the old velocity, but let's add some dump value so our velocity will not last forever, but it's just dumped. Okay, so what we need is another matrix with we call velocity, which we call, sorry, my English is so bad. We need to add the acceleration to this, and we are now, this is our old velocity, this is our new one, and so we are retaining our velocity value frame by frame, right? So this should work. Let's see if this works. Oh yes, guys, this is totally working. This is totally working, and this is the most cool thing in the world. Yes, yes it is. So guys, this is how you build a simple particle system with Max. You can add all sorts of forces to your particle system. All the forces you like. You can do fluid simulation, you can do gravity simulation, you can do all sorts of cool stuff. Remember that if you enlarge your window, you have to click on the get size parameter. And this is it. I hope you liked it, and we'll see on the next tutorial. Thank you guys, and goodbye.